7 is, okay, so you have 4 times 3 minus x squared minus 3 minus x cubed plus 3 times 3 minus x. So if you're going to factor this, what do you notice about all three of the terms? So what can you pull out? Yeah, so start by pulling out 3 minus x, and what are you left with? 4 times 3 minus x minus what?
3 minus x to the second.
Yep, 3 minus x squared plus what? 3. Now, at this point, are you done?
No.
Not necessarily. You want to try to clean this up. What could you do to clean this up? Yeah, Aubrey. So you could actually do out what's in there, right? Yeah. So you could do 3 minus x times, what do you get? 12 minus what? 4x minus 3 minus x squared plus 3. No. Now what do you want to do? Oh, 3 to 12, so you get 3 minus x, and what do you end up with? 15 minus 4x minus 3 minus x squared. Like that? Are we done? It seems like there might be more we could do. Anybody want to guess as to what we could do? Anybody? Anything? You could do the square. So not just you have to multiply it out, right? So it's 3 minus x. And you have to be careful with that because that minus sign is floating out front, right? So that thing is minus 3 minus x times what? 3 minus x. And keep in mind, this is by itself right there. It's minus that thing. So could we FOIL that out if we wanted to? Yeah. What do we end up with? 9 minus 3x minus 3x plus what? Plus what? Not plus x squared. And we're subtracting that, right? And we have this right here, and it's times 3 like that. Now, is there something we can we clean that up a bunch on the inside? Yep. So you have 15 minus 4x minus 9, and then you have minus 6x, so it becomes what? If it's minus 6 and you have a negative on the outside, it becomes what? Plus 6x minus what? X squared. Now, can we clean that up a little bit? 3 minus x, and what do we have here? We have 15 and minus 9. What's that become? 6. We have minus 4x and 6x. What's that become? Minus what? Minus x squared. Now, we have 3 minus x, and we have negative x squared plus 2x plus 6. What could we factor out of this to make it a little bit easier to factor? What do we not like? What's the thing about that one that I just underlined there that we not like? What's the one thing there that we're not super excited about? The negative sign. So what can we factor out? If we factor out a negative, we end up with negative 3 minus x times x squared what? Minus 2x minus 6. Now, can you factor this? Yeah, you sure can. You absolutely can factor this right here. You're looking for two numbers that multiply together to get what? Negative 6. Multiply together to get negative 6, but add together to get negative 2. Are there any numbers like that? Are there any numbers like that? That's the big question. Yeah, can you think? So let's just start with the multiply together to get negative 6. If you're multiplying together to get negative 6, you could have 2 or negative 3, right? What's another way to do that? You could do negative 2 and 3, right? What's another one? You could have 1 and negative 6, or you could have negative 1 and... Are there any other pairs? Are there any other pairs? No. Do any of these add together? What is this? Negative 1. This adds together to get 1. This adds to get negative 5. And this adds together to get 5. So what can you say at this point? This is fully factored. This right here, the purple underline, it's a prime it's prime polynomial. Meaning, can it be factored with something other than integers? Yes. Anything can be factored. But in this case, can it be factored with integers? Can it be factored with integers? No, it cannot. Yes, Nick. Times what? X plus 2 times x plus 3. You would just look like that. It would be 3 things. I kind of assumed that's where this one was going.
Yeah.
I kind of assumed it, yeah. Basically, they just wanted you to do this and clean it up. That's it. 60, but add together to get negative 11. Well, look at 60. You can make charts different ways. You kind of see this done different ways. But 60, what's one way to break up 60? Like 15 and 4. and you want them to multiply together to get 60, but add together to get... If this is positive, right? If this is positive, it means that A and B both must be both positive or both negative, right? So theoretically, 60 could be what? Negative 15 and negative 4. The problem is, what happens when you add these? You get 19 and you get negative 19. Or either one of those negative 11? So you can keep on trying. Are there other pairs maybe? Sure, there are other pairs. You can do like 30 and 2. You could do 60 and 1, but do any of those work? No, so what are you going to call this one? You can call it prime. Another way you can, it's prime because where this one, if it crosses the x-axis, isn't an integer. That's something you're going to study later. But the idea is, by process of elimination, you can't find any that work with just integers. Does that make sense? Yes. The leading coefficient is 1. It is much easier to factor the trinomial or quadnomial, whatever, the polynomial, okay? But is the leading coefficient always going to be 1? No, it's not. What we're looking for is to break this up into something x plus something times something x plus something. Now these two right here, these are both coefficients of x. Those are both coefficients of x. Oh, it's not x. What is it? It's not x. It's r, right? So instead of x, I wrote that wrong. Sorry. Okay, so when I do this, you get r. Nice. Okay. So they have to multiply together to get 12. Multiply together to get 12. Absolutely. We know they have to multiply together to get 12. So let's just guess. Again, when you factor, you are going to do a lot of guessing and checking. You're going to get better at, instead of starting with this set that's infinitely big, because if you start with a set that's infinitely big, you'll never be able to pare it down. You're going to start with a smaller and smaller set as you get better at this. But now, hey, it's small. What two numbers do you want to try? Just pick two numbers that multiply together to get 12. 3r and 4r. Let's try that. Okay, so these numbers, the ones that are left here, these two, and we get a bit of color there. What do you know about the two numbers that are left? What can you tell me about those two numbers? These two numbers, what?
They add together to get 5.
Not necessarily. Nope. They definitely, they multiply together to get what? Negative 2. You know that both of these have to multiply to get what?
Negative 2.
Negative 2. Sorry, I used the highlighter there. Multiply. So can you give me two numbers that multiply together to get negative 2? Yeah, so let's try that. Let's just try it and see what happens. So we have 3r minus 2 times 4r plus 1. 3 times 4 is 12, and negative 2 times 1 is negative 2. Is that necessarily the proper factorization? All we have guaranteed right now, we've guaranteed this term and this term. Have we guaranteed the middle term? No, we haven't. So let's just try it and see what happens. We have to test it. Well, what's 3r times 4r? 12r squared plus, we have 3r times, plus what? 3r. And then you have right here, we have negative what? Negative 8r. And then negative 2 times 1 is negative. So what do we end up with? 12r squared minus 5r minus. Did we actually get it right on our first try?
Yeah.
We did. We got it right on our first try. Now here's the thing. Theoretically, did we have to start with 3r and 4r? No, the only constraints we had were they have to multiply together to get 12r squared. It could have been, what, 6 and, or 12 and it could have been reversed. You could have had 4r and 3r, right? So there's lots of different orders. You're going to test one and see if it works. Oh, it doesn't. You're going to then test another. You are going to get better and better at testing. One caveat to this. When you read your book, and later in this class, there are some shortcuts for some specific types of trinomials. The challenge with using the shortcuts is they work really quickly some of the time, but some of the time they're a waste of time. I much rather prefer you learn a general way of factoring so that when you get to the easy ones, you make it easy, and when you get to the hard ones, you make it harder. The idea is I don't want you to waste time. And while this seems like it's going to be copious and a little tedious right now because you're going to do something, it's not going to work. But you will generate an intuition. You will gather an intuition that will make these easier. So let's try another one. Another one could be, again, we're trying to factor into something that looks like this. not x. It's going to be something x plus something times something x plus something. So the leading coefficient is not 1 here, but what's nice about this leading coefficient? It's small. How many different ways can you multiply two numbers together to get 3? 1 and 3 or 3 and 1, right? There's only one way to break it apart, really, right? That's nice. It has small amount of factors. So let's guess. What do you think that first coefficient should be? Let's just guess. 3. And what's the next one going to be? 1. So let's leave it blank. Well, 1. The other two numbers have to multiply together to get what? 2. So how about 2 and 1? Could I have chosen -2 and -1? I could have, but look at the middle term. What's the middle term? Is it positive or negative? It's positive, so both of them have to be positive. So let's test this one and see what happens. What's 3x times x, Milo? Yes. That was good. What's 3x times 1? Yep. Plus 2x plus 2. So you have 3x squared plus 5x plus 2. Is that what you want it to be? No. Is it close? So what options do we have? We could try, what other configuration can we try? Well, we can't use negatives because none of the terms up there are negative. None of them are. But what can we do? 3 times 1 is the same as 1 times 3. 2 times 1 is the same as 1 times 2. So what could we do? We could reverse the order of some of them. So instead of 3x plus 2, I could do 3x plus 1 and x plus 2. Oh, well, let's try it. What's 3 times x? Ah, but now, Nick, 3x is getting multiplied by what? So what is that going to be? Plus x plus 2. What does that come out to be? Yes. Is it what we were looking for? It is what we are looking for. So you can switch the order. It doesn't change the product. So did we find it? Yes. Is there going to be a certain amount of guess and check when you factor? Absolutely. Are you going to get better at it and have like a stronger and stronger intuition? Absolutely. You're going to be able to kind of see this. The difference between someone who can do a question in their head and they have to do it on paper is not very much. It's just a deeper understanding of the topic, a feel for it. One of the reasons I like factoring is there's no one way to do it. There's lots of different things you have to learn, and then as a whole, you get better at the game, which is fact. You look at number 8, sorry, example 8, and you look at these 3 terms. What's the first thing you noticed when you looked at that? What was the first thing you noticed? The what? Negative. I heard negative. I heard negative 3x. The first thing you noticed was that A, the leading coefficient here, is not 1. What is the greatest common factor of all 3 of those terms? What's the greatest common factor? 3. So what could you pull out first? 3. Oh, I'm sorry. 3 is not in 16. Oh, sorry. Excuse me. It's not. You're absolutely right. That was that look. I was thinking, why is Liv giving a look? Okay, but what?
Group this, right?
Oh, could we group it or something? But what do we not like? We don't like the what? You said the negative, right? Can we factor out the negative? Yeah. Let's just get the negative out of there and end up with negative times what? 3x squared what? Minus 16x plus? Oh, not plus. Minus what? Okay, so that negative is just along for the ride. Now we have something that has a positive first coefficient. But we're turning this into something x plus something times something x plus something. It's 3x squared though, right? What are the things that multiply together to get 3? 3 and 1. So you have 3x and 1x. So now you just have to keep on testing until you find the right one. The other two numbers have to multiply together to get what? Negative 12. So what pair do you want to try first, Milo? What two numbers multiply together to get negative 12 that you want to try? 2 and 6 do not multiply together to get negative 12. Negative 2 and 6. So when you multiply this out, let's just multiply this part out. You end up with 3x squared plus what?
3x squared.
3x squared plus what? Plus 18x minus 2x minus what? 12. So do we get what we want? You sure?
No, we don't.
Is that exactly what we want it to be? Everybody, look up. Hands up, everybody. Is that exactly what we want it to be? No. Why not? Yeah. So this right here is positive 16 instead of Negative 16. So are we close? So what do you think we should do? If we're really close, what's the small change we can make? So we have 3x and x. What small change could we make? It's the exact same thing we did before. Just switch them. So instead of 3x minus 2, it becomes 3x what?
Plus 6.
Plus 6? Okay. So we do minus 2. Let's see if this works. This is possible. But what do we get here? Minus. Remember, it's going to be minus on the outside. We want it to be this one right here. We want it to be this one right here. That's the one we want, right? So let's try what, Milo? What's your question? You had a question.
Why do we want?
There. And we changed the position of negative 2 and negative 6. What could we do instead? Instead of changing the position, you could just change the negative part, right? So let's try that instead. So negative 3x. So instead of minus 2, what do we make it? Plus 2 and x minus what? 6. So again, what's 2 times negative 6? Negative 12. What's 3 times 1? So the original constraints are still there. All we've done is we've changed the plus and the minus, right? What's a positive times a negative? What's a negative times a positive? So it doesn't matter what order the sign is there. No. But let's see what happens to the final result. What's 3x times x? Minus 18x plus 2x minus 12. Look what happens. What do you get? Minus what?
16x.
Minus. So do we end up with what we want?
Yes.
We do. So the final answer to this would be right here. One thing you should never do, which is really important when you're guessing and checking, sometimes are you going to have to guess and check a whole bunch of things?
Yes.
Yes. This is something you should be very careful about. Why do you have to be careful about erasing?
Make sure you don't reuse like information.
Exactly. My recommendation is don't erase. Just be like frowny face, and then happy face. You need to be able to go back and check what you did. You need to be able to go back and check what you did. Okay, let's take a look at this one right here. This one right here. What's different about that one? Yeah, to the 4th power. This one right here is really different. It seems like it's really different. What I'd like you to do is keep this in your pocket for homework, like a walking around problem. I want you to think about this. I don't want to show you how to do this one. I want you to play around with this one. Not right now. You might have played around with it a little bit already, but keep that one in your notes, and then when you have some spare time, see if you can figure out how to factor that. See if you can make any breakthroughs on that. We'll come back to it, okay? Okay, we need to move on. It's going to seem like it's super overwhelming and super crazy, and it's going to give you a lot of things that you think you have to memorize, and I'm going to tell you, yes, there are some of it you have to memorize that it's going to be super helpful if you memorize them or when you memorize them. And I just did that too many times. Here's a chart. I'm going to tell you right now that you need to know this one and these two. I really don't like this one right here. I don't really like that. It's something that's important for you to know exists, but it's more important that you know the ones that are in blue. What do these tell you? They tell you this. X squared minus y squared is equal to x plus y times x minus y. This is called the difference of what? Those are cubes?
Squares.
Difference of squares. So what does this formula tell you? Let's say I gave you a squared minus b squared. What does that equal? A plus b times a minus b. Move on. Exactly, right? So what about this? How about 9x squared minus 16y squared? What does that equal? 3x minus, well, plus, sure,
4y
times,
3x minus 4y.
exactly, but minus, exactly. What happens if I gave you q squared minus r squared? Does anything change about the work? Q plus r times q minus r. Nothing changes about the work. So this right here is the first one. This is the difference of squares, the first one. The ones that are a little bit more complicated that you really do need to memorize are the difference in sum of cubes. These two right here are the ones that you really do need to memorize. You need These is in the book, yes. Memorize. And right there you have to memorize. Does it matter what is being squared? No, the formula still holds. The formula still holds. But what's really key to recognize is this. 1, 8, 27. What are those? These are cubes. What's after 27? So it's 1 cubed, 2 cubed, 3 cubed. What's 4 cubed? 64. What's 5 cubed? 125. What's after 125? What's 6 cubed? 216. These are cubes. It's really important that you recognize cubes because you might get something like this. 216a cubed minus 8. And you look at that and you're like, oh my gosh, how do I factor that? But what is 216? 6 cubed. 6 cubed. This right here is just 6a cubed. And what's 8? What is 8? 2 cubed. So what do you see there? The difference of cubes. So you can go back up here if you've memorized it. Is there a difference of cubes formula? Yeah, the difference of cubes formula is right there. So tonight, I'm going to give you a few to play around with. But the big thing you need to do for tonight, again, I'll post it as